So this last section in the domain comes to the grand conclusion about the domain. Remember, when I started this domain, I described the whole point of this domain was based on the recognition that today our valuable information assets are stored, secured, and processed on computers. And that if we intend to keep that information secure, our computers must somehow be identified as secure. And how do we do that? Well, first they have to be designed and then manufactured and then delivered and then installed and then maintained securely. And we looked at how to secure the hardware, how to design it properly, how to take advantage of segmentation and isolation boundaries. We looked at the operating system with its ring architecture and how those rings afforded us another level of isolation and boundaries, layering, data hiding. Then we looked at the integration of security in the enterprise as it needs to permeate all facets of the enterprise. And then we looked at some of the formal models that our higher level security systems are based upon. Well, now that we have all this foundation in place, we can now boil this back down to the real world. How do we turn that into knowing that a computer system that I'm going to purchase has some certifiable level of security? This is done through these components that we're looking at here. It started with the Trusted Computer System Evaluation Criteria, or the TCSEC. That was the U.S. government recognizing the need for different levels of security on different computer systems in different roles, and how to specify them and then get them certified at that level of security. The next one down is the Information Technology Security Evaluation Criteria, or the ITSEC. Now, this was a European enhancement to the U.S. TCSEC. It came a handful of years later, and they basically took what TCSEC was and expanded it to try and give more versatility and cover a few more topics. Now, the problem with these two models are that they were based on the academic models that we saw earlier, based principally on Bell LaPadula. Now, remember, Bell LaPadula also required the non-interference and the state machine models. So there were a couple models that these two criteria were based upon. The problem is those academic models didn't necessarily translate to real-world security needs. So recently, 10 or 15 years ago, the common criteria was developed. Now, the common criteria is a definition of how vendors can design and manufacture and deliver and install and maintain computer systems at a certain level, a specified and certifiable level of security. So the common criteria has 7 different levels of security that we're going to be looking at here shortly. Let's first move into the TCSEC. The TCSEC, again, was developed by the National Computer Security Center. It was written up in a book they called the Orange Book. Now, the Orange Book is one of the books in the Rainbow series. The Orange Book describes how a single standalone computer can be designed, manufactured, delivered, installed, and maintained securely. Now, it does not include the network behind this. This is simply how a single computer system can be implemented at a specified and certifiable level of security. That's the Orange Book. Again, there's a total of 26 books in the Rainbow series. Orange Book is a standalone system, whereas the Red Book is called Trusted Network Interpretation, or TNI. This is, now that we take an Orange Book machine and we plug a wire into it, do we satisfy the Red Book standards? So again, the Orange Book for the single box is based on Bell LaPadula and deals with confidentiality, no other security component. That would be no integrity and no availability concerns. The TCSEC looks at 6 fundamental requirements. First, there needs to be a security policy that defines and enforces security rules for a computer system. Second, it deals with marking, the labeling of the computer system and the proper labeling of the objects that the computer system stores, secures, or processes. It deals with identification and accountability, assurance and continuous protection of the confidentiality of the information assets that this system is going to hold or process. The TCSEC is broken up into these categories. We have category D, which is the weakest level. That identifies a minimum level of security. Category C is the next most secure level. Now, category C identifies discretionary access control. That's what most of our commercial networks operate within. So your Microsoft network and your Unix or Linux network that you're dealing with, those generally run the category C classifications. Now, the weakest level here is D, then it goes to C1, which is slightly stronger, and then C2, which is stronger still. And again, we're dealing with only discretionary access control models on the category C. On category B, we roll to a higher level of security where we implement mandatory access controls. Mandatory access control systems are used primarily in high-level military and government networks because of their massive rigidity and their massive cost. So category B is stronger than category C. As we move from D up to C1, up to C2, the next category up would be B1, and then B2 and B3 being the strongest of the Bs. And finally, we have category A, or A1. This is mathematically, formally verified protection. This is where a system has been mathematically proven to satisfy the highest levels of security for the system. And remember, TCSEC only dealt with confidentiality. So when I refer to security, I'm speaking specifically and solely of confidentiality. Again, the Orange Book was one of the 26 books in the Rainbow series that dealt with how to implement security for your valuable information assets. A few years after the TCSEC was introduced and the United States moved into it and started specifying and purchasing computing equipment based on TCSEC, a group of countries in Europe, European entities, decided they needed to enhance the TCSEC specification. So they took the foundation of the TCSEC and extended it to make it more diverse, identifying differently the scale of functionality versus a scale for assurance. And let's talk about the difference between those two. Functionality says it has the capability of doing it at least once. That's functionality. The functionality for that specification is there. Assurance says it will perform that way every time. So functionality says if I can do it once, functionally I can do it. Assurance says I can do it the same way every single time. So the TCSEC breaks those two apart and addresses functionality, can you do it at all, breaks that up from assurance, can you do it 100% of the time. And again, the European enhancement of TCSEC is the TCSEC. This diagram compares TCSEC to TCSEC, and it shows how they pretty much align. TCSEC functionality E0 equals TCSEC's level D, which is minimal security. F1 plus E1 equals C1, and you can see how they proceed and progress upward in security from there. Now, the TCSEC also extended the scale with F6 through F10 to provide higher levels of integrity, availability, and higher level of confidentiality, including on a network. So those were some of the additional enhancements that TCSEC provided to TCSEC. So the TCSEC made the TCSEC a little more granular and descriptive about the levels of security that were implemented on a particular system. So that was the good news. The bad news is it still was just an extension of the TCSEC, and as a result was based on abstract, formal mathematical models that didn't exactly match real-world security needs. So something new was needed. The common criteria was introduced in 1993 by the International Organization for Standards, or ISO. The common criteria is based more on real-world need, and it was developed by an international conglomeration of entities. ISO standard 15408 further delineates the common criteria. The common criteria addresses these security requirements for functionality. Now, they mention toe access. That could be the point of some funny statements, but toe is target of evaluation. This is the product, the computer system, that the vendor is proposing to satisfy a specific security need. So TOE is target of evaluation. That's the computer system that supposedly satisfies a security requirement. Further, the common criteria addresses assurance requirements. And again, let's put this in perspective again. Functionality says I can do it at least once. Assurance says I can do it every single time. So, the common criteria identifies what's called the protection profile. This is the government's description of real-world security needs. It identifies to the vendors 7 different levels of security required of the computer systems that the government needs to purchase. So the protection profile is the government's written description of security needs. The vendor responds with what's called a target of evaluation, or the TOE. The target of evaluation is a computer system that supposedly satisfies the security objectives specified in the protection profile. So the vendor takes the target of evaluation and then writes a report called the security target. The security target is a written description from the vendor explaining how the target of evaluation satisfies the protection profile described by the government, describing their security needs. So again, the vendor produces the target of evaluation and the security target write-up for the target of evaluation. They then provide the target of evaluation and the security target along with a big fat check to an accredited testing center. This testing center is accredited by the government to correctly and completely evaluate the target of evaluation and then declare that it either meets or does not meet the security requirements written in the protection profile at the specified level of security. That level of security that is specified is referred to as the Evaluation Assurance Level, or the EAL. So the accredited testing center will either stamp certified or not certified on the target of evaluation. Again, the common criteria has functional requirements, can it do it at all, and it has assurance requirements. If it can do it at least once, can it do it every time? And here are the 7 EAL levels, Evaluation Assurance Levels, that are specified with 7 different protection profiles. And as you can see, EAL 1 is the weakest, with EAL 7 being the strongest security. Something also to recognize is as you test at the higher and higher levels, this turns into a much more expensive computer system. And this is the flow chart, if you will, of how this all boils down. First, the government has written its protection profiles, a description of the functional and assurance security needs for computing systems that are being sold to the U.S. government from third-party vendors. So the protection profile is the real-world security needs for these computers. The target of evaluation and security target are produced by the vendor, and they describe how the target of evaluation satisfies the protection profile. Those two are sent to a third-party testing center that has been certified and accredited by the government to perform proper evaluation of the target of evaluation. If it satisfies the protection profile, it passed all the tests for the given EAL level, then that particular device receives the certification stamp of EAL and gets added to something called the Evaluated Products List, or the EPL. Certification versus accreditation. Certification says that this device meets or exceeds the minimum level of security specified by the protection profile, which aligns to the evaluation assurance level. That's certification. Accreditation is, in general, the government's formal acceptance that the testing center properly has tested and has properly certified this device, meeting a specific EAL level.